Newton's first law, the law of inertia. This first law is a law which is based around inertia. According to physicsclassroom.com, inertia is where an object resists change. This links to Newton's first law, as this suggests that objects that are at rest or objects that are moving will continue to do so unless another force is acted upon them. They only move or increase their speed or direction when they are acted upon by an unbalanced force. Someone who carries a smaller mass, such as in their weight, will have a smaller inertial value. However, someone who has a bigger mass will hold a greater inertial value. This means that the smaller you are, the easier it is to move around with agility. For example, in basketball, usually the shorter people in the team will be able to get around court a lot faster because it takes a smaller force for them to start running, and therefore a smaller force for them to slow down when they get to the end of the court. Newton's second law is called the law of acceleration. This is because, similarly to the first law, this second law is based around a factor which, for this one, is acceleration. Acceleration is a vector because it has size and direction. Newton's second law is usually described through the equation of resultant force equals mass times acceleration. However, to work out acceleration, this would switch around and become force divided by mass. The law suggests that the acceleration of something is proportional to the resultant force of an object and inversely proportional to the mass of an object. The law also suggests that gravity and air can act upon a force, which causes it to slow down, and this would reduce the rate of its acceleration. Overall, the law states that if a force is applied to an object to increase the rate of its acceleration, then the acceleration of the object will increase as the resultant force of the object also increases. However, as the resultant force decreases, such as when friction is applied, then the acceleration of the object will decrease and slow down, causing the object to eventually stop. This may occur if the mass of an object increases. The next type of force is The next law is Newton's third law, which is the law of action and reaction. According to bbcbitesize.com, Newton's third law of motion suggests that whenever two objects interact, they will exert equal but also opposite forces on each other. This means that every action is suggested to have an equal and an opposite reaction. For example, when standing ready to shoot in basketball, there are gravitational forces between the player and the ground. The ground pulls the player down as the player pulls the ground up, which means that they both have an equal sized forces and are opposite in direction, allowing the player to feel more stability. Overall, this suggests that forces are reactive and can be applied to examples where there is evidence of equilibrium.